All right. Ever stop and think how a system could possibly handle the data for an entire country? Today, we're going to pull back the curtain on the database strategy that makes these massive projects. I'm talking about things like India's national identity system, not just possible, but actually fast and super reliable. So, to really get a handle on this, let's start with a number. A huge number. 1.2 billion. That's how many people live in India. And that number, well, it created one of the biggest data management challenges in history. Seriously. Which, of course, leads to the big question, right? How on earth do you build a secure, verifiable ID system for every single one of those 1.2 billion people? I mean, that was the incredible task facing the team behind the Aadar project.
But you gotta ask, why even try to build something this massive? It wasn't just some cool tech challenge. It was about real people, real lives. You see, India was spending $50 billion on subsidies. But without a solid ID system, that money often wasn't getting to the folks who desperately needed it. So the goal here was simple but profound. Create one single unique ID to unlock essential services for everyone.
And the amount of data we're talking about, it's just mind-boggling. To give every person a unique ID using biometrics, think iris scans, fingerprints, the system had to be built to store somewhere between 10 and 15 petabytes of data. To put that in perspective, that's like storing thousands of full-length HD movies for every single person.
So, how in the world do you tame a data beast that big? Well, here's the secret. You don't. You can't. Instead, you break it up. You chop it into smaller, much more manageable pieces. And this core idea, this principle, is called partitioning. It's the absolute key to making this whole thing work. At its heart, table partitioning is actually a pretty simple idea. Think of it like this. You have one massive single encyclopedia. It's too big to use. So what do? You split it into individual volumes. A to B, C to D, and so on. That's all partitioning is. You're dividing one giant table into these smaller, independent chunks. But, and this is the cool part, the database still knows how to treat it like one single, unified thing. And there are basically two main ways to slice this data pie. Over on the left, you've got horizontal partitioning. That's just like our encyclopedia example. You're splitting the table by rows, putting all the S entries in one volume. Then on the right, you've got vertical partitioning. This is different. It's more like taking a single entry and splitting its columns. So you might keep people's names in one place and their huge biometric files in a completely separate one.
And this is where the magic really happens. It's a concept called partition pruning. It's so smart. If you ask the database for information about someone named Smith, it's clever enough to completely ignore all the volumes from A to R. It doesn't even look at them. It goes straight to the S volume, which makes the whole search process incredibly fast.
Okay, so if you're going to partition, you can't just do it randomly. You need a strategy. The way you divide your data is absolutely critical. And it usually boils down to one of three main methods. And trust me, choosing the right one, that's everything. So let's take a look at these three main strategies. First up is range. This one's perfect for anything based on time or a sequence, like creating a new partition for every month of sales data. Super common. Then there's list. This works when you have a fixed set of values, like partitioning your customers by country or by state. And finally, you have hash. You use this when you just want to spread the data out as evenly as possible. It uses a function to scatter user IDs across different partitions to make sure no single one gets overloaded.
And this right here, this is probably the single most important thing to remember if you're ever doing this. We're talking about the partition key. That's the column you use to decide how to split everything up, like the date for a range partition or the country for a list partition. And if you pick a bad one, a poor choice of partition key can actually make your performance worse than if you had no partitions at all.
So what makes a good partition key? Well, for starters, you pick a column that shows up in your where clauses a lot, something your queries are always filtering by. You also want a key that spreads the data out evenly. You definitely don't want a key that shoves 90% of your data into just one partition. And this is a big one. You want a key that doesn't change. Why? Because moving a row from one partition to another is a really expensive, slow operation.
All right, so getting the strategy right is half the battle, for sure. Now, let's dig into how you actually implement this stuff. And, just as important, how you maintain these partitions over the long haul. Partitioning isn't just some wild guess. It's a really structured engineering process. This flow here shows you the whole journey. You start by analyzing your data. And then you move step by step all the way through to optimizing your system for this new partitioned world.
Let's just break that down really quick. Step 1, you do a deep dive, analyzing your data and figuring out how it's being queried. Then, step 2, you pick your strategy, range, list, or hash. After that, you create the main parent table, you define all the individual partitions that'll sit underneath it, you load your data in, and then finally, the payoff. You optimize your queries to take advantage of that awesome partition pruning we talked about.
Now, think about a system that's collecting data over time, like monthly sales logs. You just can't have a person manually creating a new partition on the first of every month. It's completely unrealistic at scale. So the key, and this is a huge takeaway, is automation. You need scripts that automatically create the next partition before you even need it, and also drop the old ones you don't need anymore, like archiving last year's data.
Okay, partitioning is incredibly powerful, no doubt. But it is not a magic bullet. There are some really common mistakes that can completely wipe out all the benefits. So let's talk about what to avoid.
And here it is, the number 1 mistake. It's so tempting to think, hey, if a few partitions are good, then a ton of them must be amazing. But nope, that is a trap. Over-partitioning is a straight-up performance killer.
So, why is it so bad? Well, a few reasons. First, the database's query planner still has to check every single partition, even if it's empty, and that adds overhead. Second, the database has to keep track of metadata for all those little pieces, which just eats up memory. The query planning itself takes longer, and believe it or not, all those tiny partitions can actually waste disk space. It just creates a ton of complexity that slows everything down.
All right, here's another huge pitfall. What happens if your partitioning strategy doesn't spread the data out evenly? Like, what if one partition ends up with millions of rows while all the others have just a few hundred?
Well, this creates something engineers call a hotspot. That one single overloaded partition becomes a massive bottleneck for the entire system. While all the other partitions are just sitting there, idle, all your queries start piling up on that one hotspot. It just kills your performance and all the scalability you were trying to get. And that is why choosing a partition key that distributes data evenly is so critical.
But when you get it right, wow, the results are absolutely mind-blowing. Let's go back to the AHA project one last time. Because they designed their partitioning strategy so well, their system can handle an almost unbelievable number, 600 trillion biometric matches, every single day. That right there is the power of taming the data beast.
So, what's the bottom line here? What should you take away? Well, partitioning isn't just some nice-to-have feature. It's a fundamental tool for surviving at massive scale. It makes your queries faster, it makes maintenance like archiving way easier, and it's really a cornerstone of database scalability. But, and I'll say it again, its success lives and dies by one thing: choosing the right partitioning strategy and, most importantly, the right key.
And that really just leaves us with one final thought. Your data is growing. Everyone's data is growing in every application. So the question isn't if your tables are going to get massive. It's really just a question of when. Is your architecture ready for that?